Okay, you got me, Rebecca?
Yes, we've got you.
Incredible. Okay, well, hello, folks, and thanks to everyone for coming along on this day. Good evening, good morning, bienvenue to you all. Thanks for tuning in from all over the world to listen in on Wormhole Queries and all the exciting things that you can do with it. And we'll be doing a demo today as well. So let me jump straight into it. What is Wormhole Queries? What is the point of Wormhole Queries? Queries are a cross-chain data service that allows you to fetch on-chain data from any one of our supported 35 chains on Wormhole Queries on demand with the full security ensured by the Wormhole Guardian network. So in simpler terms, it's a pull model for blockchain data. You basically ask for specific state data from another chain, and Wormhole's Guardian network, the 19 Guardians, they retrieve and sign that data for you. So this means that you no longer need to deploy special contracts or wait for expensive transactions to push the data across chains. The question is, what if accessing near real-time verified data from multiple chains was not only possible, but also really easy? Queries makes this a reality, and it enables basically almost instant cross-chain reads and a unified experience for your dApps. And in summary, Wormhole Queries is amazing because it speeds up your cross-chain interactions and it cuts costs by about 87%. And ultimately, it can unlock new use cases, which we'll talk about, by providing you your secure, tested data across chains on demand. So at a high level, Wormhole Queries leverages the existing Guardian network. So all of our 19 independent actors in sort of a new way to fetch data. And the architecture itself has a few key components that we'll run through. So we have a query proxy server, which is a allow-listed off-chain service that you call via an HTTP REST call. And this receives your query request and broadcasts it into the Wormhole Guardian network. Each of these guardians then will independently validate the incoming query. It will perform the required blockchain calls on the target chains, and they run full nodes and archive nodes for each supported chain, and you'll get a signed result. Each guardian will respond on its own. They don't need to talk to each other. And just like a normal Wormhole message, you will get a supermajority, so at least 13 of 19 of these guardians. They will sign off on the same result for it to be considered valid. And the proxy waits for a quorum of matching responses until those are gathered and aggregates those guardian signatures into the Wormhole messaging primitive, which is the VAA. And it returns the final attestation back to you once quorum is reached. And this response includes all the original query details, the data result, and the guardian signature set. Then you can consume this on-chain. The query response, which is essentially a Wormhole VAA containing the data, can then be submitted to a smart contract on the originating chain or any chain to be verified and then used. And then this uses the Wormhole on-chain libraries to check the Guardian signatures using a SIG verify function to extract the data for use in its logic. So this is a way to access Guardian attested data on demand with the full security of the Wormhole network. The whole process is very, very fast. It's typically under 1 second for a valid query. So on EVM, you're looking at around 400 milliseconds, and on Solana, you're looking at around 800 milliseconds. If the Guardians can't get a result immediately, they will keep trying for up to 60 seconds before these time out. The neat other thing that you can do is you can also batch up to 255 queries at once. These can be arbitrary function signatures and across multiple chains in one query to maximize efficiency. So you can pull 255 bits of data across, I think it's so, just to be accurate, it is now 38 chains, all in one, and you can do multiple function signatures. And what can you do? Right now, you can do ETH calls, so your typical vanilla ETH call against a block specified by your number or hash. An ETH call by timestamp, where you can specify a specific timestamp. And you can also do an ETH call with finality, where you will specify that the specified block has reached finalized or safe for returning the query results. You can also query Solana. Now, this is very exciting because Wormhole Queries is the most robust, verifiable source of Solana data. You can pull Solana data over to the EVM and you can verify this whole thing on-chain. So you're basically becoming your own oracle. You can do this. There are many other amazing use cases. These are some of the supported chains. These are not all of them. All the Wormhole connected EVMs are supported. We support these chains with finality. Optimism is supported with finality as well. And let's jump in on how you might want to use this. So we can walk you through how you might want to build and send a cross-chain query using query TypeScript SDK. We can use a simple example. We will query a constructing a query. We will query an ERC20 tokens total supply from Ethereum Sepolia testnet and get the result tested by Wormhole. We want Node.js installed, create a project directory, install the Wormhole Query SDK and any needed dependencies. And you'll also need an RPC endpoint for the target chain and an API key as well, which you can request directly from yours truly via the Wormhole Query beta program. Also, a little bit of alpha. We're coming out of beta very, very soon. We will be including a very, very cool query builder, which you'll be able to use to actually construct these queries yourself. And then you'll be able to also validate your own queries as well as the queries you've created on testnet. And then you'll be able to deploy to mainnet or permissionlessly, which will be super exciting. So constructing a query request. In your Node script, you import the SDK, define the query details. For an EVM ETH call, you'll need the target chain's Wormhole chain ID. In this case, if it's Sepolia, it's 10002, the contract address, the call data, and your function selector and your encoded params. And so for total supply, the function selector is OX181600DDD, and you should also pick a block reference. It's often just the latest block number. This is the mock environment, and you can then get an idea of what this all looks like. This is exactly how you might construct a query and exactly how it might look. The next step is sending the query to the proxy. We will now send the serialized query bytes to the Wormhole Query proxy via its REST API endpoint, including the API key in the header for authentication. Now remember, this is a current limitation, but this will be removed as we come out of beta very, very soon. Keep your eyes peeled, and please, please message me in the meantime for your API keys. You'll then want to parse your response. So using the Query SDK, we can parse the return bytes to get a structured query response object. Now, chain response.results here will contain the raw return data of the total supply call in hex. So for ERC20 total supply, this is a 32-byte unique 256 value, and we will want to decode it. So this is the full demo and how it looks. And then you want to run the script, basically. So this is then how you then verify the response on chain. So let me run you through a couple of demos on how this all looks here. So just bring this up a little bit. So let's try querying ETH Sepolia for the name of USDC on the USDC contract on ETH Sepolia. Now you can see here, here's the block number, the block time, and the block hash itself that we've called. This is your result. It's returned the result, which is the name of the contract that we've specified on USDC, on Sepolia. And I can actually quickly, good idea for me to quickly show you how that looks as well in terms of your query. Quickly, this is how the query is going to look. You've got here your Axios, you've got your RPC, you've got your function, and you've basically got here your return here. So this is what we're looking for. We're going ETH get by block number. We fetch the latest block. We query the USDC contract name on Sepolia. Apologies. Let me pull up another one here for us to check out. It's Sepolia. Here we go. Here is the actual name of USDC on Sepolia. So you can see here we have, just put that one down here. We've got the chain ID, we've got the data that we're looking for, we've got the RPC, we've got the contract that we're querying, which is the USDC contract on Sepolia, and then it's basically going to return the data, which is the name data that we've asked it to return, and a little emoji letting us know that it's been successful. Let's try another one. Let's try a Solana PDA. So what we're verifying is that this is a simulation, and we're simulating an owner verification of a specific NFT on Solana. And you can see here that we verified that this account owns this specific PDA, and we can see here's the owner, and here's the account value. It's been verified at this time on that slot, and that is us verifying Solana data, which we can then pull over to the EVM and verify directly over there. Now, another one here, let's talk about the Oracle use case. Let's pull the price data of ETH to USD on-chain, last updated, what's that? It's a different time zone. This was last updated some couple of hours ago, by the looks of it, the last time that this was updated. So we can actually go ahead and query that again. We can check out a balance of an account as well. We can see here the balance is 12.87 ETH. Here is the address. We can check the balance as well. Just to note, this doesn't represent real value. Yeah, that's a balance query. Another really, really neat one is we can check the redemption rate of Jito Sol. So you can query a stake pool on Solana, and this is the current Jito Sol stake pool rate. So you can actually check redeem rates for all sorts of LSTs and LRTs on the EVM and on Solana. This is really, really cool because it actually lets you, as within your DApp, within your DeFi DApp, actually provide a real-time on-chain redeem rate and be able to price assets appropriately. So you can, pull the SUSDE to USDE redeem rate for Athena. You can pull that from Solana, and then you can consume that on Arbitrum, should you so wish. So that's also really, really exciting. Let's actually see another one here. This one, the name of USDC. I have a couple more here that I can show you guys as well. So let's talk about actually some use cases, some real world use cases that are powered by Wormhole Queries today that I want to show you guys. One is really, really cool. It's called Infinix. It's a great DApp. It's basically a platform that provides a SEX-like exchange experience on chain, built by the team behind Synthetics. It's gaining a lot of popularity, and Infinix uses queries to enhance user security and cross-chain asset recovery. So for example, if a user's funds become stranded on a non-EVM chain, or an unexpected state occurs across the bridges Infinite can just query the state of those assets on demand via the guardians and initiate recovery procedures across different chains. So they use Base as a hub, and they can pull non-USDC funds stuck on non-Base EVM chains using Wormhole Queries. So Wormhole Queries underpins the entire of Infinix's account recovery flows. You pull the state, you sync it across the chains, and then you can have all the security guarantees of the Wormhole Guardians on demand in just under a second. So rather than needing to actually produce a state change, you are just reading that state. It takes 400 milliseconds, plus the Guardian attestation, which takes around, which takes under a second to get verified. You are then away. This is very, very interesting, and it just provides a safety net across multiple ecosystems, and it really aligns with their goal of like providing a really seamless trading and user experience. The other one that's really, really cool is WorldCoin. WorldCoin maybe needs no introduction. It's a decentralized ID protocol designed to provide universal access to the digital economy. And WorldCoin uses Wormhole Queries to integrate with Solana. So imagine a Solana dApp needs to verify that a user is unique, is a unique human, as proven on Ethereum, where World ID is originally recorded. So instead of relying on a centralized service to do this, WorldCoin queries the state root of the Ethereum-based proof of personhood and seamlessly just pulls that over to Solana with full attestation, and they can authenticate a World ID proof that lives on Ethereum. So the Guardian network fetches and signs the proof data, and the Solana contract can then trust the result using the Solana verify example, which is a huge step for cross-chain user authentication. And we can ensure real humans use Solana apps using Ethereum's identity system. The other one is Uniswap. So Uniswap uses all of its cross-chain deployments to new chains. Obviously, Uniswap operates on many chains. Uniswap uses Wormhole Queries for its governance messaging. So one can view certain governance queries as its own use case. So you can check if a proposal succeeded on Ethereum from BNB chain, and Uniswap pulls the latest governance state, like proposal outcomes, time lock statuses, or the approval of a new deployment from Ethereum when needed, instead of waiting for events to be published. So we use this for governance. Other cool use case is multi-gov. So we have actually productized this into a multi-chain governance system, which is really, really neat, that you can use today. So Wormhole Queries powers multi-gov, which enables voting across multiple EVMs and Solana. Soon we'll also be supporting the Move VMs. And as a DAO, you have a hub chain and spoke chains, and then you can create proposals which will then automatically be generated on the hub, and you can have your voters have their tokens across every remote chain and have them participate in your governance processes. So this goes hand in hand with obviously the reason that you would want to take tokens cross chain, to have them accessible by different ecosystems. Different chains have different benefits. Some are faster, some are cheaper, some are maybe more secure. And this way you can have token deployments across remote chains, and you can still have all of those token holders participate in governance, which is really, really exciting. So this is how the multi-gov system works. And there are some really exciting use cases happening which are similar to this. Some major DeFi protocols are using Wormhole Queries to enable cross-chain sync of state, things like cross-chain borrow lend, really, really interesting. And yeah, we're keeping DAO governance accessible and flexible. So it's really, really exciting, and keep your eyes out for this as well. This is about to go live for everyone to be able to leverage. The other use case is Jido. So Jito uses Wormhole Queries to update the Jito Sol stake pool rate. So you can see here the actual stake pool rate itself being updated periodically. So they run a crank turner. It's like a cron job or just like an off-chain lambda, and that basically just initiates a wormhole query. It comes to life once a day. It initiates a query, and then it will pull the redemption rate of Jito Sol from its stake pool. So when expanding Jito Sol to other chains, e.g. they've expanded to Arbitrum, they use Wormhole Queries for these rate adjustments periodically, essentially a purpose-built Oracle contract. So using this, they just fetch the on-chain Solana stake pool info in a trust minimized way, and then they feed it into the Arbitrum contract that manages the ERC20 Jito Sol. And that means that on any chain, Jito Sol remains accurately pegged to the underlying stake Sol value, and it reduces ARB opportunities, and it just keeps things really nice and neat. So this means you have a more transparent and up-to-date experience for your Jito Sol holders on all chains, because price updates are based on Guardian verified on-chain data rather than off-chain price feeds. So you can basically build your own price feed here, which is really, really exciting. So some inspiring, I guess, some inspiration on what you can build with Wormhole Queries. There are quite a few exciting things that you can build with Wormhole Queries. I was going to share a couple of ideas to maybe spark your imagination. Each of these could be a great hackathon project or its own DeFi tool. You can build a cross-chain NFT metadata aggregator, which will pull NFT data from multiple chains on demand. For example, verifying an NFT's attributes or its owner on Ethereum when it's listed on a Solana marketplace. So with queries, a Solana program could fetch Ethereum NFT metadata in real time. Another one is a multi-chain DeFi dashboard. So a dashboard that displays a user's portfolio across multiple chains with live data queried on demand. So instead of relying on subgraphs or separate APIs, you could use Wormhole Queries to fetch balances, token prices via on-chain oracles, or loan health factors from various chains whenever the user opens the app. And the data will come straight from the source contracts, attested by the guardians, giving users a one-stop and trust-minimized view of all of their holdings. The other one is a decentralized Oracle aggregator. So you could enhance Oracle reliability by querying multiple independent on-chain price feeds and aggregating those results. So, for example, a smart contract could use queries to fetch BTC price data from Chainlink on Ethereum, Pith on Solana, and Band on Binance Smart Chain, and then average all of them. So you have like a averaged out price feed through an Oracle aggregator. So Wormhole Queries can supply all those feed values in one go, secured by the same guardians, and effectively act as like a meta oracle across chains. That would be something amazing that I would love to see being built. Basically like a meta oracle where you can input what price feeds you would like. You could provide some price feeds out of the box, and then you could also have like a simple natural language interface that even lets users pull price feed data for directly from smart contracts for any token that they might be interested in. So for example, you could come to this and say, hey, I would love to know the redeem rate of SUSDE, for example, on Solana. And it will construct a query for you, which you can then consume on EVM. The other one is a cross-chain identity and reputation system. So expanding on the world ID concept, a dApp could check a user's reputation or creds that live on another chain. So you could imagine a lending protocol on Polygon querying an Ethereum layer 2 credit score contract, like Lens, to decide on loan terms. Or you could have a game on Solana that queries an Ethereum addresses ENS domain or POAP NFTs to help customize the user experience. You could make that happen seamlessly with Wormhole Queries. completely robust on-chain and in a decentralized way. So each of those ideas take advantage of the unique strength of Wormhole Queries. You can fetch live on-chain data, you can ensure it's verifiable, you can do so quickly, and you can really help break out of silos of single chains and build apps that will view the whole blockchain world as one connected data universe. So another demo I'll show you guys is a simple demo that uses queries to sync counters across EVM chains. So I'll show you guys just this demo UI that I've just done. You can increment these counters to sync the state across the chains. So let's increment the counter on the base side. Let's go with that. I need to just switch. I need to just switch counts here. 1 second. Just switch accounts over very quickly. There we go. Back here. Alrighty. Alrighty. Okay, let's try that one again. So let's increment the counter on base. Polia, you received the response in 403 milliseconds. We confirmed that. There's the transaction we've submitted on base. Waiting for that to go through. And there we go. We've caught update counters. It's happened that quickly. We've updated the state. The total count has increased. Here's the contract itself. And you can see here that we've pulled this example, updated the counters, and this app is available for you to test out and try today. So coming back to the reach of queries, it's currently on every available EVM chain that Wormhole is connected to. So all the EVMs that you see here, you can query today. You can query Berachain, you can query Monad, you can query Inc, and you can pull that data across to any of the other chains that are connected to Wormhole today. You can actually consume this data wherever you want, ultimately, if you just deploy the Solidity SDK over there. So basically, the use cases are pretty much endless. We're evolving some new features out. We have support for Cosmos, so you can consume queries on Cosmos using an example that we built and expect Sui as well as the other Move VMs to be supported later this year as well. And I would definitely recommend you checking out the TypeScript SDK, which is what I've been using today to create these queries. I would recommend checking out the Solidity query response library, which you can use to parse and verify these queries. This is the query response library. This lets you verify any query on chain. It's installable via Foundry, or check out our GitHub, and this provides the iWormhole interface that you need and the helper contract to verify the signatures and pass the data on EVM chains. So this just lets you parse and call any of this data that we've discussed. We have a Solana verification example, which is quite robust. This can be used for verifying and parsing your queries on Solana. This is essentially how you want to use it. You want to post signatures, verify your query, and then you can close signatures in case that was invalid. It's pretty easy to use. It's easy to build. If you have any questions about the Solana side, please feel free to reach out. To experiment, you will want you'll want an API key as well, which I can issue you. The format of the response signature as well is just the ECDSA signature, which is calculated using Sign, and you can learn more about the key usage in the Guardian key usage white paper. But you'll notice that this is very much standardized across all chains. So again, going back to our examples here, which I can share with you guys as well after this, might be helpful to look into how a Solana query looks as well. Let's start with the EVM here. So you've created a directory, you've set this up, you've run npm init y optional to initialize, and you've installed the query SDK and Axios, which helps with your RPC calls and your HTTP requests. Make sure that you have your API key as well. You can set it in your shell if you want for convenience, and we also need the RPC URL for Sepolia. You can then choose your token contract. So for this demo, we can use the Chainlink ETHUSD price feed contract as a stand-in. It's not ERC20, but it has a similar function for demonstration. And you can call here your data. You're calling the name of the, it's called the Circle USDC contract. You can just call the data here. And you can pull the latest block, and then here are your parameters. You're just pulling the latest block. You're not pulling the finalized block. You can also pull the latest finalized block. You create your query script basically, and then you can just fetch your data. Once you've assembled this, you just need to send it. You just create a query request with one per chain request. In this code, actually, after sending the request, we return bytes into a query response object, which is always helpful. That just contains array responses. You can add in different arrays for each chain's answer as well, so you could query multiple chains with this too. Once you run this and execute it, you'll see your output, which we just pre-coded in here, which we've seen before. So some verification tips actually. You should always verify the data out of band when testing. You can call total supply via a direct RPC to see if it matches the query result, or you can also use the Wormhole Explorer or your own logs. The query result can be decoded by the Wormhole Spy tool to also ensure that the Guardian signatures were present. This isn't usually needed though on testnet unless you're debugging signature issues. But once you've deployed this in mainnet, you'll want to triple check everything. You can use the Spy tool to decode the VAA to make sure that those signatures were present. You can use that from Wormhole Scan. You can also alter the query. So I would also try altering the query by a couple of parameters just to see what the output changes to accordingly. Like you could do a different block number or a different function like decimals with its signature to see that the output changes in the way you're expecting to. And if you get timeouts, just ensure the API key is correct, the query format is right, and Guardians won't respond if the contract address or the data is malformed, but you will get an error response for that. This again just shows a simple single call query, but you could do this across multiple chains all at once. You can imagine doing this on 5, 10 chains all at the same time and querying the same data, averaging out, say, price feed data, like we mentioned. The time and the gas savings would be enormous. So actually, What I'll do after this is I'll also share, I have written up a demo of a batched price feed query with multiple calls and one request. So we pulled separate price feeds from separate oracles. And again, this is the same. You'll walk this through in the same way. You'll set up your scripts. You'll prepare your query calls. You'll test those out. When you batch 2 calls and send a query, you'll get the raw results in hex strings corresponding to the ABI encoded return data of the latest round data for each feed, and then you will just decode the int256 price from each result to display a human readable price, for example. So actually some tips when you're batching queries. All calls in one per chain query request must be for the same chain and the same block. So you cannot mix different chains in one per chain query request. You'll need to use multiple per chain requests just to keep the call results in order, so you know which index corresponds to which call. And if one of the calls fails, the entire query might fail, or that result might be empty. So you might want to handle that accordingly. But in most cases, static calls like view functions won't revert unless given bad parameters. So if you decode the price, that's just for like a demonstration, but an actual application contract might not need to decode all values if you only care about one. But you have the full tuple if needed, basically. The other one that I have written up, which I will share with you guys after this, is a mock credit score query. So a multi-chain call for a credit score request. So let's say, back here. Let's say that you have a scenario where you want contract on Sepolia to receive data from both Sepolia itself and Solana DevNet before making a decision. So the use case is a cross-chain credit score. So you'd suppose that a lending protocol wants to check a user's reputation on Ethereum or an EVM chain and some data on Solana. So maybe like a Solana program that tracks credit history. So we'll fetch an EVM call on Sepolia, like a user's score from an EVM contract, and a Solana account data call on DevNet, which will be the same user's score from a Solana program account. So you would need your Solana CLI or key pair, and you'll set up a simple Solana PDA account that will store a score or pull a DApp that uses that. And if you're not familiar with Solana development, don't worry. I'll provide a mock program address for you and assume a value. So just giving you some homework for this afterward. So the Solana DevNet chain ID, you plug in there. So we'll assume the Solana program stores credit scores and derives an account for a user's wallet. We'll have a user's Solana wallet and the PDA account data, which scores a single unit 32 score, just for simplicity. So we have an account that contains a 4-byte value representing like a user's credit score, and then you would export those environment variables, the EVM contract, the EVM user, and the Sol account. For the EVM side, you'll need like a contract that maps user addresses to scores. If you don't have one, you can deploy like a dummy on Sepolia, or you can just skip to the actual data verification. So we can assume the contract has a function get score for the address and user, which maps to unit 256. So to create the dual query request, you'll import the needed classes. You need BS58 as well, Axios, and you need the query SDK, those 3. We can include, the base 58 for the base 58 decoding of Solana addresses to bytes. You'll have some constants, so you'll have the EVM contract, the EVM user, the Sol account, as well as all the original ones, the Sol chain ID, the EVM chain ID. And for Solana, we'll need the public account key, the public key of the account in bytes. So you'll need to base 58 decode that. When you construct the multi-chain query, we create 2 per chain query requests, one for EVM and one for Solana. For EVM, you use the ETH pool query request on get score address of the contract, and suppose it has like a specific selector, then the data in reality, you'll get it from the ABI or remix, but the data will equal the selector plus the 32-byte user address. And you want to pad that address to 32 bytes and remove the OX prefix. For Solana, you use the Solana Sol account query request to fetch that account's data. You could also use the Sol PDA query request if you had the seed, but here we have the address directly. So we can just do that because we have the account, the account directly, the address. So you want the latest block for EVM as before, and then you build the results.
Hey Oz,
yes.
Can you hear me? Did you
Yes.
mean to unshare your screen? Because we currently can't see your screen.
Oh, whoops! No, sorry. I think my
okay.
I think my screen timed out.
Oh, no problem. Just letting you know. Cool. Infinite screen again, looking good. Nice.
Let's go. Perfect. So when you actually construct, once you've constructed your multi-chain query, you'll need the latest block for the EVM calls as before. You've got your ETH pool query request. You've got your Sol account, and once you've constructed that, you've built the requests out, and you can create one query that includes both chains. You'll then send and parse that, very similar to the examples here that we've shared before, and also the examples here. So you'll want to send and parse that. You've got your ETH pool query request. Here you've also got your Solana account query, request as well. So you just combine the two. You assume the EVM contract get score returns a unit 256 as well, and then you can run this query, and the sample output might look like cross-chain. So you've got your EVM response raw, your Solana response raw, and then you'll have a Solana account score value and an EVM contract score value. So that's like a hypothetical output of how that looks. And I'll share that example with you guys after this as well in a doc where you can test out some of these examples that I've shared. So I guess then the takeaway is that multi-chain queries can allow for complex cross-chain conditions to be checked with just one user interaction. So in a lending DApp, the user could click apply for a loan, and the app issues one query that gathers all the necessary proofs from various chains and submits those to the loan contract in just one transaction. The Guardian network has handled both the EVM and the Solana RPCs under the hood. It's a direct read of account state on Solana, and you've used the Solana account query request for a direct account. You can also use the PDA query request if you need to derive PDAs by seeds on the fly. Guardians will do that derivation for you. This is also very useful if the account address is not known, but it can be derived from, say, a wallet and a program ID. So some tips for the verification on that side. You want to use the Solana CLI or the Explorer. So you want to run like Solana account XYZ to see the data of that account in depth to ensure the bytes match the expected value. And for EVM, you can call the contract's get score on Polia via like Ethers or Remix to see that it returns what you're expecting, which was 50. And then you can check the Guardian signatures count, and the return VAA covers both. So you want to check that the VAA is one that contains both chain responses as part of the payload. You can decode this with the SDK offline because the Wormhole Explorer does not fully decode the CCQ payload just yet. So yeah, with that, you will have shown a cross-chain query involving an EVM chain and Solana, and that will showcase pretty much the full power of Wormhole Queries. They're not limited to one ecosystem. You can fetch from any supported chains in one unified request, and as support for more chains comes online, like Cosmos and Move and Sui, you can conceivably pull data from 3 or more different virtual machines all at once if needed. So yeah, these demos pretty much will sort of show you the technical steps you need to use queries. In a real-world app, the off-chain portion might actually be done by a backend service like some cron job or some Lambda function. we're working on enabling web apps to directly call the query proxies themselves, but the on-chain consumption portion is really useful for the trustless guarantee on-chain. In some cases, using the data off-chain with the knowledge of the attestation might suffice. For example, like a read-only display in a UI, you might not need to submit and verify the VAA on-chain. So again, you can access this really powerful service and you don't need to actually submit or attest those VAAs every time on-chain. Actually, in local environments, you can also run this this query proxy mock method, which is neat as well if you don't want to jump straight into testnet. The SDK has a query proxy mock class, which simulates real responses without hitting the guardians. This is really useful for unit testing. But yeah, I'd encourage you to experiment with writing the different query types. You can try ETH call by timestamp to query a specifying timestamp and find it via the corresponding block. You should try ETH call with finality as well. So asking for the latest finalized blocks data on Ethereum. This is super useful. All governance-based use cases should really use ETH call by finality. You want the latest finalized blocks data. If that data was already present previously, you're just making sure that the latest finalized block also has that data in it. And if you're Solana savvy, you should try the Sol PDA queries. You can provide seeds and the program, and the guardians will return the account data if it exists within that. This is really, really powerful as well. And each of these is documented in these docs here. But you can refer to the white paper for the exact binary format if you're curious. I would definitely recommend checking out the white paper if you want to check the exact binary formats. You can see here, this is how signature verification looks, and this is how the actual server works as well. Anyone can run a proxy as well to trustably forward those requests on to the guardian. And this is the spec exactly. So this is how you would want this is how the exact binary works basically. For normal ETH calls, with ETH call by timestamp, you'll want these hints here. The resulting blocks are always different. And yeah, the block hints are actually optional now, but this is always critical. For ETH call by finality, the finality can be finalized or safe, but not all chains support safe. The request does have to include, though, the block ID and the finality level. We call it the consistency level. So this is also worth checking out. The concept of finality in Wormhole, we call it a consistency level, is measured differently for different chains. So for sure, you're looking at Ethereum, you're looking at a few epochs, which takes about 19 minutes, but you can actually specify this to be instant or safe. Safe is just one epoch, so 32 blocks. With Solana, you're either safe or finalized. Again, this is about 1 to 2 seconds in Solana, and vice versa, so on and so on and so forth. I will include these for you here in the follow-up PDF, which has the examples as well as the multi-chain examples for you to try. The Sol account and Sol PDA query types are detailed out here. I would highly recommend checking this out if you're interested in Solana. It will show you exactly how you need to construct these. And yeah, basically, by completing the demos that I share, you're pretty much ready to build, something that would normally require a custom oracle or a lot of waiting. And the queries will abstract all of that and let you focus on your application logic. There are some really, really, like me personally, am excited about so many of the use cases that can actually be built on top of this. What's interesting is that, today, something like 75% of all cross-chain interactions are token transfers, but the percentage of use cases for arbitrary data are increasing rapidly as it becomes more and more important for us to be able to, truly use attested on-chain data and not just an RPC call. What does this provide over an RPC? Well, the pricing model is actually fantastic. You essentially, as we come out of beta, we will be introducing a stake for access. So you'll essentially stake quite a nominal amount of tokens, just a pretty much a nominal amount in order to gain access to a specific rate of queries. So you will be rate limited. You can access like 1 query per minute or 1 query per second tiers. You can increase that, so you could do, you can have 1, 2, 3, 4 queries per second by increasing that rate. And it's just used as a form of DOS protection on our side to protect the guardians from DOS type attacks. Some other ideas, I think some other really interesting ideas are, like multi-chain FT or game inventory, the multi-chain collateral or credit score. I think a light oracle would be really neat. Here we go again. Time out. Screen. I could just finish up here though. Like a light oracle would be amazing. So using queries to fetch your DEX spot prices or aggregated quotes from various chains and returning like a single price feed to any chain wanting like an attested global average price. There are potentially huge cost or time savings versus spinning up a custom bridging solution or paying an oracle for using its price feeds for that. A Solana stake pool aggregator would also be amazing. So just allowing projects to easily show the real-time exchange rate from Solana using the Sol account queries. Then the EVM can trustlessly verify the stake pool ratio or total stake land ports in a single step before performing an action, which is great for staking dashboards. A KYC composer would be amazing as well. So you could query the user's sort of is KYC status from Ethereum or other chains to return attested statements for destination chains to confirm that data on the spot. And this would replace your typical update the whitelist on each chain approach and just let you unify all the compliance logic in one place, but still enforce it across all the other chains. And again, I recommend looking at Infinex, Jido, Uniswap. We have some very exciting other integrations coming up. Pith uses Wormhole for a lot of its price feeds, and essentially they use the query system for a lot of the price feeds that they provide, like a flavor of Wormhole Queries that they've built. So this is really exciting because we're basically opening up access to this really powerful data product for everyone to use. And yeah, I mean, I'd love to follow up with anyone after this. I'm happy to take like any questions. You can feel free to message me directly on Twitter, or you can message me on Telegram. That is my Telegram there in the chat for you guys to be able to reach out direct. Please reach out. I'm very happy to help you with any use cases you might want to build. Happy to help with anything you might want to build. Basically here to help, give you an API key, give you access to mainnet and testnet as well, walk you through what needs to be done for your use cases. Happy to spitball on any exciting projects you might have in there. And yeah, I see we're nearly at time, so I'll hand it back to Rebecca.
Hello, hand it back over to me. Yeah, I'm really excited to see what people end up. I'm hoping you can hear me. I'll keep talking and I assume you can hear me. Amazing. I'm really looking forward to seeing what everyone builds. I'm hoping that Wormhole Queries will be a big part of the hackathon coming up. So I hope this workshop has been really useful for people and a resource for them to check back on. There is, of course, the workshop from last year as well, but I think this one trumps that. So yeah, it's going to be really exciting. Thank you, Ossie, for coming in and giving the session again. And I'm looking forward to seeing what people end up building with them.
Amazing. Thanks so much, Rebecca, and thanks everyone for tuning in. And please reach out direct. And yeah, reach out to Rebecca. We'll work out with Rebecca how to follow up on the with all the demos for everyone to try out as well.
Cool. Thank you everyone for joining us. We'll wrap up here now and see you again on Thursday for the next session. Have a good rest of your day, everyone.
Thanks, Rebecca. Thanks, everyone.
Bye.